How to configure OSPF for CCNA students. CCNA students need to understand how OSPF works, but also how to configure it. If you have no idea what OSPF is, or if you are a little fuzzy, I recommend you read my introduction to OSPF first before continuing. Having said that, let's configure OSPF. This is the topology we will use. So I'm going to set up this topology in GNS3. I don't really have an Ethernet interface, so we're just going to use fast Ethernet. Oh crap. Just put this in the background. How do I send this to the back? There we go. Alright, let's configure router 1 first. Phase F00, IP address 2168.12.1 with a /24 subnet. /24 subnet, or am I saying it right? It's /24 mask. /24 shut /0 to submit ask of /24 shut the address 168.168.3 F 168 13.3. Actually, since these are Ethernet, which has a bandwidth of 10 megabits per second, I should manually set the interfaces here for router 1 FA00 and router 2 FA00 with a bandwidth of 10 so that I can emulate this topology. OSPF costs. Oh wait, no. How do I do that? Bandwidth. Oh, over here. 10. Crap. Kilobytes. So what was it? It should be correct. 10 megabits per second. Here, interface F00 and with 1000. All right, this is the topology we'll use. All routers in the OSPF area 0. Note that the link between R2 and R1 is an Ethernet link. All other links are fast Ethernet 100 megabits per second. We'll start by configuring R2 and R3. Alright. OSPF. Zero. Oops. OSPF 1. Alright, so essentially what that does is it sets this network here, any interface that is on this network, set so that it's considered to be an area 0. I need to use the router OSPF command to get into that OSPF configuration. Number 1 is the process ID, and you can choose any number you like. Doesn't matter if you want to, you can use a different number on each router. The second step is to use a network command. It works similar to RIP, but it's slightly different. Let me break it down for you. network 192.168.23.0, 0.0.0.255. Just like RIP, the network command does two things. Advertise the network that fall within the range of OSPF, activate OSPF on the interfaces that fall within the range. This means that OSPF will send hello packet on the interface. Behind 192.168.23.0, you can see that it says 0.0.0.255. This is not a subnet mask, but a wildcard mask. A wildcard mask is a reverse subnet mask. When I say reverse subnet mask, I mean that there's binaries. Ones and zeros of wildcard masks are flipped compared to the subnet mask. A subnet mask 255, 255, 255, 0 is the same as a wildcard mask of 000, 255. Don't worry about this too much, and I'll explain the wildcard mask to you when we talk about access lists. OSPF uses areas, so you need to specify the area. That's what area 0 is for. In our example, we have configured a single area OSPF. All routers belong to area 0. After typing in my network command, you'll see the following message in console. Yeah, I see that. It's right here. Great, it seems that R3 and R2 have become neighbors. There's another command we can use to verify that they have become neighbors. So do show IP OSPF neighbor. Do show IP OSPF neighbor. Looks like R2 is the DR. Although this is point to point, so it doesn't really matter. Show IP OSPF neighbor is a great command to see if your router has OSPF neighbors. When the state is full, you know that the routers have successfully become neighbors. Each OSPF router has a router ID, and we will check it with the show IP protocols command. Above, you will see router IDs R2 and R3. They are using their highest IP address as the router ID. Let's create a loopback on R2 to see if the router ID changes. Hello. IP address 252.255.255.0. And I'm not sure if loopback interfaces are on by default, so let me check. Show IP and brief. Yeah, I don't need to no-shot it. This is how you create a loopback address. You pick any number that you'd like. Doesn't really matter. Oops. There we go. Nope, the neighbor ID stays the same. We need to reset OSPF's process before the change will take effect. So let's do that. And write clear ID OSPF process. Yes. Show IP protocols. Nope, the router ID remains the same. but in his version, it changes it to 2.2.2.2. Why is that? What if I were to shut it down completely? And restart it. Show IP protocols. The router ID did change when I restarted the router. Still checking, yeah. But I want to actually check online to see why that is. Their IP OSPF process doesn't change router ID. Now, we are in the process of readdressing, loopback IP address, IPs of routers and core switches. I have the OSPF router ID associated with each device, which would need to be changed post-loopback readdressing. After I readdress the loopback and enable routing on the new loopback, we're planning to do the following. What if I wanted to change it? Here, let me go to router 3. Oops. Let's do that 0. IP address 3. Nope, it's still the same. Show IP protocols. IP OSPF. Nope, still the same. What else can I do? OSPF. Oops. Router OSPF1. Router ID. What if I manually set it? OSPF. Oops. Protocols. Am I still, yeah, I'm right to 3 now. Cool. Awesome. We can also change the router ID manually. So we kind of already went through this. Changing the router ID isn't something you would normally do. IP addresses on your router have to be unique, so your OSPF router ID will also be unique. Understanding how OSPF selects a router ID is something you have to understand for the exam, however. Right now we have an OSPF neighbor adjacency between R2 and R3. Let's configure our routers so that R1 or R2 and R1 and R1 and R3 are also OSPF neighbors. So going to router 2, T, router OSPF1, network 92.168.12.0. That's this right here. And a wildcard mask of 0.0.0.255 with an area of 0. On router 1, we have router OSPF1, network 192.168.12.0, wildcard mask of 0.0.0.255, area 0. And we'll also advertise the .13 space 68.13.0. And lastly, .0.0.0.255 area. OSPF neighbor. Cool. OSPF neighbor. IP OSPF. One of them is an X start. What does that mean? What does that mean? Okay, it's updated. I'll advertise all networks in OSPF before we check the routing table. It's a good idea to see if our routers have become OSPF neighbors. Excellent, our routers are OSPF neighbors. Alright, let's check the routing table. Route OSPF. R2 has only one entry. It's for network 192.168.13.0/24. What are we seeing here? This O stands for OSPF. This network. It's the network that we learned. It's the link between R1 and R3. So that's this. $110 is the administrative distance. The 20 is the metric. But why is it 20 here? OSPF interface 00. Cost is 10. The cost is also 10 here. Why is that? F0. Yeah, I did configure the bandwidth, right? And this should be 10 megabits per second. Yeah. Half duplex. Zero, zero. Yep, it's 10 megabits per second. Why is the cost 10 here makes sense, but cost 10 here doesn't make sense. OSPF. At least we can manually set it. E or FA00. There's no bandwidth, but I can do costs. F00, the OSPF costs 1,000. Show IP route OSPF. So the other path no longer shows because it's a crappy route. OSPF. Show OSPF interface 0, 0. monetize loopback addresses now. Interface router OSPF. Or what did I do? Should I do route OSPF? Alright, looks like 2.2.2 is advertised, so ping 2.2.2 should work. Awesome. The great thing about loopback interfaces is that they are reachable just like normal interfaces. You can ping them. You can can also advertise a default route into OSPF. This might be useful if your router is connected to the internet and you want to advertise this to other routers. Alright. Default information. Oops. Router OSPF. Default information originate always. You need to use the default information originate command. If you don't already have the default route in your routing table, then you need to add the always keyword. As you can see, R1 and R3 have learned the default route from R2. Shell IP OSPF. Oops. OSPF. Oh, there it is. Shell IP OSPF. There it is. Authentication, I'm not going to go through that because it's pretty self-explanatory. But actually I should. It's useful to practice. It 01. Right. Yeah. OSPF authentication, OSPF key secret. New OSPF authentication, OSPF authentication key secret. Debug OSPF packet. Yep, so this is from .1. There it is. But from router ID 222, we get auth1 code. Alright, so debug all. Interface. One. OSPF. Oops. Yeah. OSPF authentication. Message digest. OSPF message digest key 1 MD5 key. Here it 0. Oops, config T 01 and F01. Oops. The OSPF authentication message digest. The OSPF authentication message. Oops, not the OSPF message digest key 1 MD5 no key. Do debug. OSPF packet. Auth 0 from router 2. Get auth 2 with key ID 1 from router 3. In the example above, I enabled authentication per interface. It's also possible to do this for the entire area. This might save you a lot of time. Let's go to 3. OSPF 1, area 0, authentication. Zero authentication message digest. What if I have both? What really happens? You show one section. You show one section. OSPF. Did that work? It would override it. Show IP. Show IP route OSPF. Alright, it looks like we can configure the dead and hello timers per interface. Alright, cool.